Hey, this video is going to go over pH, pOH, and your hydrogen ion, hydroxide ion concentrations. So this is going to be on page 10 in your packet. In the lesson from last week with your projects, you should have discovered about the pH scale because it had you recreate the pH scale, and you had to place some things on your pH scale. So you had to research some things, find 6 things, and you had to find 3 acids and 3 bases. So acids, we know by now, have a low pH. So somewhere less than 7 are our acids. So anything that has citric in it, that's going to be an acid. Coffee, sodas, battery acid, stomach acid, all of that stuff is going to be having a low pH. A lot of the cleaning supplies that we use in our houses are going to be bases like ammonia, bleach, baking soda that we use we use it to neutralize some stuff. Anyways, bases are going to have a high pH. Acids have a low pH. If it has a pH of a 7, it's going to be a neutral pH. So it's neither an acid nor a base at that point. Now, pH, we say, is the power of hydrogen. So pHs are telling us about the hydrogen ion concentration. Okay, so this is, since it has pH here, talking about the hydrogen ion, and we know that hydrogen ions is something that acids have, and that acids dissociate, producing that hydrogen ion in solution. So since acids are dissociating into hydrogen ions, acids have a lot of hydrogen ion concentrations. So if it has a low pH, it's going to have a lot of hydrogen ions in solution. If it has a high pH, it doesn't have a lot of hydrogen ions in solution. And one thing I want to point out here is a lot of times you will see ion concentration written in scientific notation. All right, so if you see something that says, 3.4 times 10 to the negative 6 or something, versus like you might see a 2.1 times 10 to the negative 11. I want you to remember that this number here, the exponent, is telling us how far away from the decimal point it is. So it's not necessarily the first number that's telling us about how much hydrogen ions is in solution. We're really interested in that exponent number because these are negative, so these are all going to be less than 1. You can see in here in this chart. So if it has something to the negative 6, that means it's 1, 2, 3, 4, 5, like this. Where if it's something to the negative 11, it's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So this one is really low, has a low hydrogen ion concentration, where this one has a higher ion concentration. Okay, so make sure you pay attention to those exponents and what they mean. All right, so this point over here is really important. The more acidic a substance is, the more hydrogen ions it has dissociated in the water. Okay. So we're just going to match this up right here to relate our hydrogen ion concentration and our pHs with acids and bases. So we know that acids have a pH of less than 7. We know that bases have a pH that is greater than 7, and neutral substances have a pH of 7. All right? If it has a low pH, so if it's an acid, it has a pH of less than 7, that means it has a high hydrogen ion concentration. So which of these choices over here means it has a high hydrogen ion concentration? This one up here, bases have a low hydrogen ion concentration, so that's going to be this one, and neutral substances are going to have a hydrogen ion concentration right around something times 10 to the negative 7. And it doesn't matter what that first number is. If it's times 10 to the negative 7, it's going to indicate that it's most likely a neutral substance. All right, so we talked about pH, and pH is measuring the hydrogen ion concentration. So if we see something with pOH, pOH means that it's measuring a hydroxide ion concentration. So we want to remember that acids have a low pH, And we know that bases have a high pH. And because that's measuring how much hydrogen ions that they actually have. So if something has a lot of hydrogen ions and it's producing a lot of hydrogen ions in solution, it's going to have a little hydroxide ion. So if something has a low pH, that means it's going to have a high pOH, meaning it has very little hydroxide ions. If something has a low if something has a high pH, that means it's going to have a low pOH, because a high pH means it has a really small amount of hydrogen ions, which means it's going to make a lot of hydroxide ions having a low pH. So pH and pOH have an inverse relationship. If one is high, the other one is low, okay? So you can see over here in this picture here, this relationship between a pH and the pOH. So ammonia, for example, it's going to have a high pH. It's a cleaning substance. A lot of our cleaning substances, like I said, have high pHs. So if it has a high pH, it's going to have a low pOH, okay? So does ammonia have a little or a lot of hydroxide ion concentrations? I said hydroxide, didn't I? So the hydroxide ion concentrations for ammonia is going to be high because it has a it's a high pH, a low pOH. The hydrogen ion concentration is going to be low because it has the high pH. Okay. So just to recap, here's everything written out. I did make acids red because they turn litmus paper red. I made bases blue because bases turn litmus paper blue. Anyways, acids are going to have a pH of less than 7. It's going to have a low pH, okay? Acids are going to have a hydrogen ion concentration that's greater than 10 to the negative 7 because they have a lot of hydrogen ions. That's what acids do. They produce a lot of hydrogen ions. The pOH is going to be high, though, because they have a low hydroxide ion concentration. Bases have a high pH, so that means that they have a little bit of hydrogen ions in solution. Because they have a high pH, they're going to have a low pOH, and the low pOH signifies that they have a lot of hydroxide ions in solution. So what I want you to do now is the practice that's on page 10, where you're looking at a chart and you're trying to relate those different substances as far as their pHs go, pOH, hydrogen, and hydroxide ion concentrations, all right? So just let us know if you have any questions as far as that goes, and good luck.